What's going on, guys? We're gonna do the amino acids, peptides, and enzymes. I'm gonna have to break it up into 2 videos, which kind of sucks, but whatever. Okay, so we'll start with amino acid. Here's the alpha carbon, carboxylic acid, and amine group. Pretty simple. Only L configurations are found in the body, so if you ever see a D configuration, it's not in the body. So I wouldn't really worry about that a whole lot. Here is the list. Here's negative, and they have acid in the name, so glutamic acid and aspartic acid. Positives are lysine, histidine, and arginine. The way to remember at least these, I haven't made acronyms for the others, is his lies are basic, so his lies are, and then they're just basic. Obviously acid has it in the name. I haven't made names for the polar, aromatic, and nonpolar, but it's serine, cysteine, threonine, asparagine, and glutamine. Aromatic is phenylalanine, tyrosine, and tryptophan, and then nonpolar is glycine, alanine, valine, leucine, methionine, isoleucine, and proline. So a couple things that he had on the slides is that lysine competes with arginine in cold sore medication. There's not enough studies done on it to make it so it can statistically be said that way, but that's what's hypothesized. Peptides are composed of amide bonds. So if you look at the ides and the ide, that's how you can know which one it is. And then cysteines, so it kind of sounds like an S, can have a disulfide, so there's that S again. So cysteine and disulfide bonds. And of course, cysteine has sulfur in it. So that makes it easy. Globular versus fibrous. Globular is highly folded. Fibrous is stiff and linear. Globular is normally soluble, and fibrous is normally insoluble. And they gave us 3 examples. They gave us the parathyroid hormone. And so the disease associated with it is hypoparathyroidism, and that just deals with how the tooth mineralize. I'll stay on the globular. So we have mucins, and they are glycoproteins, and how they have pathologies. They're overexpressed in asthma and bronchitis. Fibrous, normally insoluble, like I mentioned. It's collagen, it's found between the cells, and it's associated with scurvy. And how to get rid of that? Well, scurvy is associated with low vitamin C, so you just drink some orange juice. How to denature proteins: heat, pH extremes, and detergents like alcohol and other things. So we're gonna move over to start the enzymes. So we have these cofactors, and cofactors kind of aid enzyme activity. So they bind near the enzyme active site. So for iron, it's like heme. For niacin, it has an N here, so it'd be NAD. So that's kind of easy to remember. Riboflavin, it has this F here, so it has the FAD and FADH2. Vitamin B6, it's also called, I'm gonna mess up this name, pyridoxine. And it's associated with PLP, or it's also called pyridoxal phosphate. So the name is here, the N's are here, the F is here, and obviously you should know that iron is associated with hemoglobin, just kind of basic. So here's some enzymes of the oral cavity, and then we'll do another video. So here are the digestive, alpha amylase. It catalyzes the cleavage of disaccharide bonds in the saliva. Lingual lipase is also found in the saliva, and it catalyzes free fatty acids from triglycerides. So think of lipase like lipids. Lysozymes catalyze these are digestive enzymes. Lysozymes catalyze cleavage of saccharide bonds necessary for gram-positive bacteria. So think that they lyse the wall, I guess, of the gram-positive bacteria. salivary lactoperoxidase. The peroxy would give away that it's H2O2 or peroxide, and it makes the hypothiocyanate ions. These guys are antimicrobial. And then the pathogenic enzymes are collagenase. It's released by host immune cells. Typically, you don't really want that to happen because this is how like you get periodontal disease. But anyways, that's how you break down gingival collagen. And then glucan sucrase. This is secreted by bacteria to break down glucose, sucrose, and fructose. And this is how like you get that glucan matrix that can build up and it binds to the teeth. So this is pretty much the amino acids. I'm gonna take a picture of it and then I'll probably make a Anki card out of it as well. So yeah.